asked to use the Moivre's theorem to solve the following equation. So if z squared, z cubed, so the Moivre's theorem states that, say if the number is in polar form, the whole complex number, say to the power of n, is equal to r to the power of n by cos by n over angle and sin and n over angle. So, sorry. There, it's a bit clearer there. So I'm going to have to write z in polar form. So z cubed is equal to 8. That's going to be 8 plus 0i. So if I'm to get the modulus of that, the modulus is going to be square root of 8 squared plus 0 squared. So that's going to be just a square root of 8, so that's going to be equal to 8. And my angle is going to be 0 because it's just 8, there's no I component. So it's going to be 0 degrees. So if I'm to write this in general polar form, it'll be 8 cos 2 pi n, because when n is 0, it'll be 0 cos of 0 plus I sin and 2 pi n. So that's our angle, 2 pi n. So that's going to be z to the power of 3. But I'm looking for z by itself. So z is going to be 8 to the power of third by cos 2 pi n over 3 plus I sin, and it's going to be 2 pi n over 3. So if I'm going to figure this out, so I'm going to get so I'm going to get 8. So firstly, I'm going to have to just maybe get 8 to the power of third, which I'm pretty sure is 2. So it is 2. So 2 by cos 2 pi n over 3 plus I sin 2 pi n over 3. So now, because it's z cubed is equal to 8, there's going to be 3 solutions. So I have to let n, so for the first solution, n is going to be equal to 0. For the second solution, n will be 1. And for the third solution, n will be 2. So for my first one, I'm going to let n equal 0. So it's 2 cos 0 plus I sin of 0. So I'm going to put that into my calculator. So 2 cos of 0 is 1, and sin of 0 is 0. So it's going to be 2 by 1, so it's going to be 2 plus 0i is our first one. And then we're going to have n is equal to 1. So it's going to be 2 cos 2 pi over 3 plus I sin 2 pi over 3. So I'm going to work that out. So it's going to be cos 2 pi over 3, which is minus a half. So that's going to be 2 by minus a half. And then I want to get sin 2 pi over 3. It's going to be plus root 3 over 2. And then if I multiply those two by 2, I'll get minus 1 plus root 3i. And now I'm going to have to go on to another page. Bear with me for 1 second, because I'm after running out of space. So now I'm on to another page. Sorry for that. So I've got n equals 0. I've got n equals 1. The last one I have to get is n equals 2. So it's going to be 2 cos 2 pi 2 over 3 plus I sin 2 pi 2 over 3. So that's going to be 2 by cos 4 pi over 3 plus I sin of 4 pi over 3. So now I'm going to plug that into my calculator. So I'm going to plug cos of 4 pi over 3, and I get minus a half. So it's going to be 2 by minus a half, and then I'm going to get sin of 4 sin of 4 pi over 3, which is minus root 3 over 2. And then if I multiply this by 2, I'll get minus 1 minus root 3 I. So the first answer I got was 2 plus 0i, then I got minus 1 plus root 3i, then I got minus 1 minus root 3i. And that is our answer. Thank you.